just looks the same as the picture. We're at, I think, a really exciting time for the bird crew right now. We spent the first couple of years on the ranch really just trying to get a framework in place to talk about or to study what we've got and to set up a monitoring scheme. And we're at the point now where everyone that works on the bird crew really knows the property, we know individual birds, and we're starting to really expand in the questions we're asking and actually some of the technology that we're using to study things. So I'm going to talk a little bit about, this is kind of another pilot technology study, using these autonomous recording units to study birds. And the reason we kind of got started in this is Debbie and I went to a conference in Vancouver last summer, where, if you can imagine, there were 3,000 bird nerds, and Debbie and I were right in the middle of all of that. But we went to several talks on using these units to study bird populations, and so we kind of brainstormed about how we might be able to fit them into our system and maybe play around a little bit with them. So that's what we're talking about. And I should mention, Debbie's really spearheading this, so she's done a lot of work on this. First question is, what are we even talking about? It's a pretty simple concept. An ARU is what I'll be referring to these guys as. It's basically a microphone, it's up here on this unit, a storage device, and a power source that basically lets you, like our remote camera system, record what's going on with sounds without a person actually having to be there. And most of what I'll be talking about today is this kind of setup that we have to document nocturnal flight calls. The array doesn't need to look like this, but Debbie has it set up so that the microphone is actually elevated to increase our ability to capture these overhead flight calls. But we have different microphone arrays that we can work with, and we're playing around with that. Why would we even use these? Here's another charismatic picture of a station. These are really good units for studying species that make noise but may be difficult to see. So I'll be talking a little bit later about bats as a species, or a group of species that these things work really well for. Things that are flying at night or that are active at night, things that might be easily disturbed. So we had a great meeting with FWP this week about sharp-tailed grouse reintroduction and documenting maybe where some historical populations have been. Are they even there? And we could set out a unit like this in historical lek areas and potentially document the species without having to take people in there and disturb a sensitive bird. It's also good for studying species that are active at times or locations that are difficult to survey. And so for us, we don't really want to be crashing around the property and disturbing everything that's out there, but we do want to know what's going on in places like the boondocks. So we were thinking, that's a remote area. We don't want people going in there all winter to observe things. Maybe we could use them back there. For species that are active at night, like a lot of our owls. We don't necessarily need to subject someone to stalking by a mountain lion out there. We could set some of these units up to record the information that we're trying to get. One of the really interesting applications for this, people are trying to use these to do point counts, so the standard method that we've been using. So instead of having a person out in the field for 10 minutes, you'd use this type of unit to record instead. So it's really kind of hard to figure out what's going on. People use technology like radar. That doesn't necessarily tell you what species are flying over, but it can give you a kind of a count. So can we use these maybe to separate out kind of species or groups of species and see what's going on during songbird migration? Birds use these flight calls when they're migrating. They echolocate by them and they kind of communicate with each other. These calls are distinctive to species, and I think in some cases to individuals. We're going to kind of group them into two groups just because I think that was, these groups were easy for Debbie to kind of separate out, and we can't look at every single individual and species. So we're going to call the warblers and sparrows kind of fit into a category. We're calling them the seep calls, and you'll see that throughout this little section. And then the thrushes, like this bluebird, are just called thrushes. So they have distinct characteristics when they're recorded and when we look at them in a spectrogram, and then when automated detectors are parsing through the data. So here's some of the questions that we came up with related to nocturnal flight call monitoring during migration. First of all, how well do these perform? Are they able to pick them up? We have them at different locations, and does that vary by location? What are the best methods for placement and charging? So this is just kind of a methods thing, like, you know, what's the best array? How do we reduce interference, because we do get a lot of other sounds on the recorders. And then if we manage to capture data, what do we do with it? I mean, it's a lot of data to handle. How well, there's automated software out there for handling data. Well, how well does it perform? Is it going to perform well enough for us to actually learn anything from it? Can we improve that software? Do we see any spatial and temporal trends during the migration season? And do we see any differences between what we're picking up on our detectors and what the Avian Science Center is capturing the next day when they're doing their songbird banding? And actually, I think we'd expect that there'd be some differences between the birds that are choosing just to fly over versus those that are stopping over. So we put up three of these units. We came back from Vancouver, and unfortunately, migration was already happening when we got back. So we were a little late to capture the whole season. But we did put up 3 units at varying elevations, and we began monitoring beginning of September and went through the end of October. So we've got a range of elevations. We wanted to capture different habitats, and kind of our expectation is that, you know, birds aren't necessarily even flying over all of these elevations, but we might see some differences. So we've got floodplain site, that same old sheep camp, and up at the ridge near the raptor observation site, if you guys ever went up there in the fall. And then I'm saying we on here, but it's really Debbie, used automated flight call detectors to scan 1,600 hours of audio recordings, and then she used some algorithms to separate out those seeps and those thrushes. And just so you can kind of get a look at what these look like in the spectrograms. Here's a hermit thrush, Swainson's thrush, white-crowned vesper sparrow, and a Savannah sparrow. I don't know if this is going to work because this is pretty soft, but we can see if this, play. I can't even hear it on here. Okay, well, we'll just skip that. It really just goes beep. So here's some of the questions we were trying to answer. Debbie did all of these analyses, and so one of the questions was, do these nocturnal flight calls vary spatially and temporally? And I'm not as familiar with these graphs as Debbie is, but we'll kind of look through them. So we've got basically the number of detections on this axis and the date here. They're separated out by the 3 elevations and then also by the thrushes and the seeps. And yes, so this is early in the season, this is late, kind of like our mapping project in the shrubby draws. It kind of shows the pattern we would expect to see, that our detections decline over time. Okay, so that's good, because again, if they didn't do that, then we'd know something was wrong with our methods. We did see more activity at the low elevation site, so that's kind of that light blue on here for both groups of species compared to the mid and high elevation site. We think a lot of these patterns that we're seeing might be related to the availability of food and water through the season and at the different sites. It's likely that we missed a good chunk of migration, and when I saw this, what really jumped out at me is that this ridge site, the high elevation site, actually had a lot of these seeps, the warblers and things early in the season, and I really want to know what was happening over here, because I'm wondering if we just missed a lot of that activity. So again, these are kind of the refinements of these methods for next year, things that will be kind of changing. How did our detections compare to birds captured and banded by the Avian Science Center? Really, we saw the patterns varied by site, and I'm just going to look at 2 of them. Here's the floodplain low elevation site. So again, this is the number of detections or captures through the season. The things that we detected on our detectors are in blue, separated out by the seeps and the thrushes, and the things that were captured in the morning are green. We saw a much higher number of detections with our units early in the season. Like this one is pretty crazy compared to what was captured. And again, that makes us wonder, what did we miss even before that? Kind of comparable numbers mid-season, but we lost the thrushes using both methods by the mid-late season, but they persisted longer using these units. Here's our mid-elevation site. We hardly detected anything on our units, and for a place that seems like during the day in migration, such an awesome place for birds to be, they weren't necessarily flying over it, or if they were, we weren't detecting them. So that could suggest maybe that they're not flying over this site. I actually don't know that much about migration ecology. I'm sure there's other people in the room that know more about it, but some of the features that people say birds could orient by are things like the river and the mountain, the mountain range. And this site is kind of right in the middle. So that might be one reason why we're not picking up much here. It might be related to the heavy daytime use of an ephemeral food source. That's something we observed firsthand. And the majority of the banded thrushes were American robins who seemed to remain in that area until they depleted the berries that were there for them. So these birds are using that draw during the day, and we're not necessarily seeing a lot of birds passing over at night. So this is kind of a really interesting question. How do these automated processes compare to a manual review? We could probably pay, a high school student or someone to just manually review all of our data, but we really don't want to be doing that. And it's the similar, problem we have with all of our imagery that we're collecting from our cameras. It's just giving us a lot of stuff. How do we handle it? So we want it to be automated at some level. Well, Debbie kind of did a subsample. She just picked out a few days and did a completely manual review compared to the automated detectors. And then she also threw in the number of banded birds in there just so you can see. But it really looks to me like the automation is not capturing a lot of things. And that could be significant depending on what your research questions were. Background noise was a real problem in separating out calls in some situations. And then the faint calls were not being picked up, but Debbie was able to pull them out herself. So it really suggests that we need to develop better automated software. Most of these projects also most of the people that are doing this type of research are in the East. That's where a lot of the resources are. And so there's not as much work or resources for Western birds, Western individuals. So there's a lot of room for improvement with the technology. So that's kind of a little, snippet of some of the research we started, but we are doing some other things with these units. We have currently 3, and we're going to be getting 3 more. So one of the things we're doing are using these to detect uncommon and cryptic species. And this is kind of analogous to, we're out doing point counts and we just happen to see a really cool bird, kind of like that incidental. We pick things up we weren't expecting. So it was pretty amazing when Debbie started picking up barn owls, because that's a species we've never documented on the ranch. They're not common in our part of Montana, and she picked them up quite a few times in the fall. And that when she first got it, we sent it around to lots of people. It sure sounded like a barn owl to us, but you never want to just go out and say that. So we had it verified by many, many people as a barn owl. The other kind of cool one on here is the common poorwill. That's a species. It's cryptic. You can barely see it in that picture. And we hear them kind of incidentally. But it'd be great to know a little bit more about where they're at. We might pick them up on a point count, but they're generally singing or calling in the evening when we're not out surveying. We do detect sounds other than birds. I thought this is a pretty cool figure. So this is just showing kind of everything that you could potentially pick up. Got an airplane here, great horned owl, coyotes, and Highway 93 early in the morning. So. And then what we'd like to do is use it to detect things like owls and other similar species in a remote area. So Debbie went in this winter, I guess a few weeks ago, and installed this unit out in Davis Creek, so out in the boondocks. It's an area, you know, if I had to have my guess where we're going to pick up a barred owl or a screech owl or something like that on the property, our greatest chances are in here. But you guys know what the access is like in the winter, and again, we don't want to be bothering a lot of wildlife by going in and owl blasting all the time. So we've got this set up out there. Debbie went out and just checked it to make sure that it was charging, and she had a saw-whet owl hooting in the first, you know, couple nights of it recording. So that's pretty cool. I don't know if this, it didn't seem to me like this is working, but you can kind of see that, you kind of saw how they were set up, and we know from Alan's movies that you pretty much put a stick or perch out and a great horned owl is going to land on it. And we had great horned owls that set up shop on all of our ARUs, which really obscures nocturnal flight calls. But here's a pair of them that were hooting back and forth to each other, and just really neat picture, I thought. Yeah. So here's kind of a new direction that we're going, and I'm really excited Christy's here because she's been supporting us on this or giving us some information. The other really neat group of species you can use this technology for is our bats. You need a different, our units, you know, they're detecting different things for bats and for songbirds, but the units that we're going to purchase can handle both. This is kind of, this awful picture is like really our only bat detection on the property. Other than Matt Larson snagged a little brown bat while fly fishing down on the river, like that's it. And we need to know a little bit more about it. This is a Townsend's big-eared bat. We picked it up while misnetting for saw-whet owls in 2010. It's a bat that roosts in mines and mine shafts, which we don't really have suitable ones on the property. So that's pretty cool, because where did this guy even come from? And it was a mess to get him out of the mist net. But anyway, that kind of prompted kind of our interest in it. It's something we don't know very much about, and it just turns out that the state is also incredibly interested in bats right now, and there's an initiative kind of with the Heritage Program in concert with FWP to set up bat stations like using the units we're using all over the state. And I know that's kind of blurry, but we can blame Bryce for that. He sent me these figures. So large red circles where we already have them installed, purple ones planned, funding pending, you know. So there's a lot of monitors out there. Don't really have any in the Bitterroot. Well, we've got some farther down here, and Christy knows more about where they all are. But 2 minutes? I can do that. What these allow us to do is answer some really basic questions about species distribution, seasonal activity, bat migration, baseline data prior to the arrival of white nose. This is kind of one of the main fears in the bat community right now. White nose syndrome, it's that fungus that you may have heard about. It's responsible for wiping out, it's kind of like chytrid, wiping out huge populations of bats in the east. It's not currently in Montana. You know, we have some things going for us. It's transmitted from bat to bat, and most of our bat species don't aggregate in these huge colonies like they do in the east. This fungus is somewhat temperature limited, but with climate change and other things, who knows what's going to happen. We want to know what our bat populations are like now prior to that coming, so that we have you know, an estimate of how it's affecting us. Also, bats are one of the top groups of species that have been affected by wind development. So when they've done the surveys at Judith Gap, it's not necessarily birds that are getting killed in the turbines. It's a lot of bats. So the state knows very little at this point. They put in a unit near the Zortman-Landusky mine, if you know that area. In 1 year, it produced 71,000 files. 10,000 bats were detected using software. They had some people do a manual review and added another, you know, over 1,000 detections. And that one unit in 1 year produced more records than we have ever in Montana. So that's pretty amazing. And we can add to that. It's a really great project to add to what the state's already interested in doing. Here's some just potential sites on the property. You know, bats are active. They found even year-round, which was not expected, as long as they have open water. So we're going to try to put up some of these units in areas where we know we have water year-round. And we already have one unit out, thanks to Christy. She had an extra unit that was available, and with members of the local caving club, they've been really involved in monitoring bat populations. It's an amazing citizen science initiative. They came out and they're more than happy to help us with anything related to bats on the property ever. We put this unit in down by the pond on the clubhouse floodplain. And I think Debbie just pulled the card and we'll know if we have some data pretty quickly. So here's just our current and future work. Keep monitoring the floodplain, Davis Creek. We're going to be doing more stuff in spring and fall migration. In the breeding season, we're going to set these out in some of the places where we suspect we have poor whales breeding. And we have flammulated owls on the property. They're active at a time when we're super active doing songbird things. So we'd like to use these units to document a little bit more about flams. Year-round monitoring of bats. And then we're going to be improving methods both to help us and hopefully to help other people trying to use this technology. And there she is. See, she's even out at night checking these things. But thanks to the Avian Science Center for sharing their banding data, and Old Bird, who's helping with the software, and Christy for the bat photos. Okay.